So welcome all. Today we are going to see something about basics of language and grammar. So we will start with alphabet as we have seen earlier also, but again it is alphabet. What have we seen about alphabet? It is just a finite non-empty set. Usually you represent this alphabet with a symbol sigma. So you can have this sigma is equal to a set, suppose 0 or 1 or sometimes A, B or whatever symbols you want to keep. So it is a finite non-empty set of symbols. Okay. Now if I have to talk about string, what is a string? It can be a finite. Okay, you are saying something, say something.
It is a sequence of alphabet, a finite sequence of alphabets.
Finite sequence of symbols from the symbols which are from the alphabet. These symbols should be element of alphabet. Alphabet is a set. So if your alphabet is AB, then a sequence of symbols which are A and B can be possible. Suppose it is U. U can be A, B, A, B. This is one string. Another string can be something like A, B. Okay, this is also a string. Suppose W. W is just A only. No problem. All of these are string. So such variety of strings can be there. Can I say that you should have a way to represent length of a string? How to write this length of a string? Is there any symbol? Length of a string. It can be written as mod.
Mod of.
Yeah, definitely. So if W is something like suppose A, B, B, then mod of W. Length of W is number of symbols in this thing. So what is the length of W?
5.
Yeah, definitely 5. There is one thing we call it lambda or sometimes epsilon. Okay. So if I find length of lambda, what it is? Or
0.
Yeah. So it is basically the empty string. You can also call it as, let me write in red, it is null string. So what is null string? A string with no symbols. It can be represented sometimes with lambda or sometimes with epsilon. Okay. So length of this epsilon will be 0. So next thing that I can tell you is concatenation. What can this concatenation mean?
Merging of symbols of string.
है ना, merging of two strings. Suppose you have two strings W and V. Suppose W is something like A and V is B. Then WV will be, can you tell me, WV will be?
A B.
Okay. Can somebody tell me what will be VW?
Then B A.
B, A. Okay. It means it is W and V. So, first of all we will have the symbols of W and then the symbols of V. है ना? If it has been written in a different order, then depending on the order, since it is V, so the symbols of V and then the symbols of W. This was the story of concatenation. What is the next thing that I can say? You would be aware of reverse of a string. Reverse of a string. Reverse of a string means, suppose your string was W, then you can represent it like this, WR. Okay, suppose W was A, B, then WR will be, can somebody tell me?
B A.
Okay, in the reverse order, right? So B and A. Very simple. You would have heard about palindrome. What happens in palindrome? What happens in
Yes, sir.
palindrome?
We have given a string, and if you reverse that string and if you match the original string, it will be equal.
Okay.
That means same.
That means if you reverse the W, you will get the same thing, right?
Yes, sir.
Okay. You can also say that the string itself is in a fashion where before the midpoint, whatever the string is, after the midpoint, it is in reverse order. Is it so?
Yes, sir.
So I can say it is something like W reverse, right? Or sometimes you can have something in between. So you can say W and something and then W reverse. Is it? All these things will be palindrome. You would have heard about substrings.
Yes, sir.
So substring is
Contiguous sequence of character in a string.
contiguous. What have you said?
Contiguous.
Contiguous, yes, contiguous or consecutive, whatever you say. So sequence of contiguous string from W. Sequence of consecutive symbols. Okay, consecutive symbols from string. Yeah. So if at all you have something like let us take some W, B, A, B. Okay. So you can have some substrings. What are the possibilities of substrings? A can be a substring. Yeah, it is there. A, B. Can it be a substring?
No, sir.
No.
ABB cannot be a substring. Okay, then ABB is not a substring. Why? Because consecutively ABB is not present here. However, AAB can be a substring, because I can see here it is,
Okay.
yes. So similarly, if you think about ABA, yeah, it is present here, so it is a substring. So similarly, if a sequence of these symbols are present in the string, then it can be called as substrings. Now, all of these things, several possible substrings are there, no problem. Can I tell you about prefix? Okay. Prefix. What is a prefix? Prefix will be a string which is before another string to form a whole string, right? U is before V to form a whole string W. Okay, suppose your W is AABA. Then what are the possible prefixes? What are the possible prefixes? We can understand, taking a substring A, we can have prefix AAB. Yeah, it is possible. Taking a substring BA, AA is a prefix, no problem. Taking a substring ABA, one prefix is A, no problem. Is there any other prefix? Can you guess? Is there any other prefix?
Sir,
Sir, whole
whole
string is
string
also a
can
prefix.
also be prefix, yes, sir.
Whole string, huh?
Yes, sir. For null string.
Okay, suppose let us take null is a string. So this is the prefix, right? Okay, so you have A, B, A. This is also a prefix. Is there any other possibility? If
Null string itself.
okay, so if you take the whole string as a substring AABA, so for this substring lambda is a prefix, right? So you can write here lambda. This is also a possible prefix. Now let me tell you about suffix, right? Suffix is similar to the prefix. Let us talk about suffix. So what is suffix? Suffix is also a string, let me call it V, which is after a string to make a whole string. Okay. So for example, similarly in the last example, if W was AABA, then suffixes can be, what are the possible suffix? Same thing, considering these all the things. If at all AAB is there, then a possible substring is suffix is A. Then BA is a possibility. Then ABA is a possibility. And then the whole thing AABA is a possibility. right? And then lambda is a possibility. This was the story of suffix, right? Now, if I tell you about you have already known about concatenation. Let me tell you about power of a string. Power of a string. So there is a string and power is 1, so it is the same thing, w, right? If at all the power is 0, what does it mean? It is lambda or epsilon. If I say power is 2, then it is concatenation of w with the w. If the power is 3, in that case w with w 3 times. Similarly, if the power is n, what does it mean? W, 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 it is concatenated how many times? N times. Okay. So this is the case. Suppose, for example, you have w is equal to ab. Okay. So w to the power 2, what does it mean? It will be ab, let me say to the power 2, it will be ab, ab. Okay. This is the way we actually write. Sometimes you may have something like w to the power m plus n. What does it mean? W to the power m, which is concatenated with w to the power n. No problem. Okay. So having said this about power, you would be aware of clean closures. Are you aware of them? Clean closures. What is clean closure? Suppose you have an alphabet. Alphabet is a set of symbols. So symbols may be A and B. 2 symbols you have. Okay. So clean closure is sigma star. Okay. What will it produce? Sigma star, it will produce every possible string with these 2 symbols. It will produce first of all epsilon, that is empty null string, and then all possible with a so on, a whatever possibilities, b b b b b b b whatever, it will also produce the combination of them, a b a okay, a b, whatever possible strings. Okay, all the possible strings with a and b. Okay, so here it is producing infinitely many strings, infinite number of strings. Now if I talk about positive closure, what happens in positive closure? Positive closure, for this positive closure you have a different symbol which is of plus. On this alphabet you have plus symbol, which says everything that you had in clean closure except the epsilon. Okay, so you had this clean closure minus epsilon. That means here you had all these things. So all these things are there, no problem, only epsilon is not there. All other strings, whatever possible strings are there, all strings are there, only the epsilon is not there. Now let me tell you about language. What is the language? So, as you have already seen earlier also, let me repeat, it is a countable set of strings, right? Set of strings. These strings as you know, they are sequence of symbols, those symbols which are part of alphabet. From the alphabet you have seen, if at all it is clean closure, this can generate all the possible strings on the symbols, right? So if language is a countable set of strings, so the maximum number of strings possible will be clean closure of the alphabet. So always a language will be a subset of clean closure of alphabet. Let me write it like a language L is a subset of clean closure of alphabet. So you can understand that this clean closure is the biggest possible language. You can also call it as universal language. Okay. Usually, how do you represent this language? A language L can be represented as sometimes if we have less number of strings, we can represent the string themselves. Suppose this language can accept only two strings, A, B, B or B, B, A. Just two strings can be accepted by this language. So it can be represented like this. Sometimes you may have to represent, a language may have several strings. So in that case, rather than writing all the strings, you can specify some pattern. Okay. Suppose for now, let me write it as A, B, okay, A, B star. Later on I will tell you that what it means, A, B star. Like it says that A is here and first character will be A, and later on it may have any number of, star means clean closure. So any number of B. So this language can accept A, B. Since this is clean closure, so it is epsilon also. So it can also accept A. It can accept A, B, B. It can accept A, B, 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 and so on. How many number of B's are possible? Any number of B's are possible. So for now, understand one thing, that we can represent a language as a set of strings. If at all the number of strings are less, you can keep the strings here. You can show that these are the possible strings. If at all number of strings are not less, there are many strings, and let me say they are infinitely many, but they can be represented by a pattern, then it's okay. You can write a pattern and specify the language. Later on we will see how to write patterns. Basically you have to see what is the regular expression. For now, let me tell you about the operations possible on language. These are operations on language. Just wait a minute. So all the languages are set of strings. So all the operations possible for set, they will be applicable here. For example, let us take two different languages. One is set of two strings, suppose A and AB, keeping simple because we will show examples also. L2, okay. Let me take AB, suppose BA, and suppose ABA3. So if you are performing union operation, L1 union L2. So what happens in a union of set? The elements of the set a union is performed on these elements. Union means all the elements are kept together. Only the elements which are repeated, they will be kept only once. So A is coming, AB is coming, which is being repeated, so it is coming only once. Then BA is coming, then ABA is coming. Done. Now if you are trying to find intersection L1 intersection L2, what is it? It is that particular string which is common between the two languages, right? So here you can see AB is the common one. You will have AB, right? In set theory, there is something called complement kind of thing, which is
Yes, sir.
universe minus the set, right? So here also, if you want to find the complement of L1, it is universal language minus L1. Okay. After that, this is L1 complement. Now let me tell you about any other thing. If you want to take complement of this thing, can you recognize it? Okay, let me write like this. It is a clean closure of alphabet which is universal language. Okay. So if you want to take complement of this, what will happen?
I think it should be epsilon.
0.
You should get a empty set. Okay. Epsilon is actually a null string. Okay. The null string is still a string, but set is empty, which means like this, set is empty. It can also be represented as phi. Okay. This is an empty set. However, lambda is a null string. So this null string can be a part of language. One language is possible which is accepting only lambda. Okay. So lambda is a string. However, this is a set. So this is an empty set. However, lambda is a null string or empty string, you can also think. So since language is a set, this is a universal language, this is a set of all possible strings on the alphabet. You are taking complement on it, so you will get no string, but still you will get an empty set. Okay. If at all it would have been a plus symbol, if at all it would have been a plus symbol and then you take a complement, what will you get? This is a positive closure. Okay. In positive closure, what we have seen? In positive closure, we have seen that it is all the strings of universal language minus epsilon. So, it is actually this inner part.
Epsilon.
Okay. Let me say this can be represented as let me not write it. Basically, you can be confused. It is what it is. It is all of it except the lambda, except the epsilon. Okay. So, here when you will take complement, you will get epsilon, okay, or lambda. There is another operation, you may call it okay. Till now, any confusion? Have you understood these things? Something if you want to ask, you can go ahead. Okay. So, for now, some other operations like set difference. If you want to perform L1 minus L2, then what will happen? You were having A, AB, and here AB, BA, ABB, right? So, you are performing L1 minus L2, which means you will get from
A1, A1.
yeah, you will get from L1 only, removing those elements which are common. So, AB, since it is common, it will be removed from L1 and you will be left with A only. So, here you will get A only. So, the difference of L1 minus L2, you are getting a language. Okay, this language is accepting only one string, which is A. Okay, no other string. Now, if you would have performed L2 minus L1, what would have happened? L2 minus L1. Can you tell me the answer? You are performing L2 minus L1.
BA comma ABA.
Yeah, only these two strings, BA and ABA. Very good. You will have BA and ABA. This thing, particularly L1 of minus L2, set difference. Set difference is also represented sometimes as the language itself minus whatever is common between them. Okay, you can write it. Oh, sorry. L1 minus L1 intersection L2. Okay, or you can write it something like L1 intersection L2 complement. Okay. Complement of this set L2 will have all the possible other strings, and if you will take common with the L1, you will get A only. So, this is also a possible way to understand it. One operation you would have heard, it is L1, you can take it as XOR L1 operation L2, what it will be? It is a kind of operation where you will have all the elements of L1 as well as L2, but not the common elements. Okay, so leaving the common elements, you will get A. You will not have AB, but you will have BA and ABA. Okay. So you already know these things. You have seen the reverse of a string. Now let me tell you reverse of a language. What can be a reverse of language? If W was element of language, this is symbol for element of, right? So this string, if W was a string of language, then if you are reversing the language, in that case you will have the reverse of all the strings. Suppose you were having whatever, suppose let me take example of L1. L1 reverse, what it will be? Since it was first was A, so A will be remain as A only, reversed, no problem. Second was AB, I think, so it will be BA, right? Now similarly, now I will tell you concatenation of string, right? No, concatenation of language, L1, L2. So what it will be? Suppose W1 was element of L1 and W2 was element of L2, right? Then W1 concatenated with W2, it is a string, and a concatenation of a string we have already seen. So one string of L1 is concatenated with other strings of L2, right? Then another string of L1 is concatenated with other strings of L2. Similarly, when you will concatenate the two languages, you will have many possible these things, strings. Suppose length of L1 was something and the length of L2 was something, right? You have multiplied, you have performed the concatenation. So now actually what will happen? One, whatever, it has 2, it has 3. So 2 into 3, 3 possible, 2 into 3, it is 6, and 6 possible strings are there, right? Now it is not always true. Sometimes what happens, actually length is this, then it is many times, I should say, length of L1, L2 is many times less than or equal to the maximum. Okay. Sometimes what happens, you will multiply the two strings and you will get same string. Okay. Somebody is trying to contact. Wait a minute. Let us say further. Actually, this was the concatenation of two languages, right? Now, if I tell you, as we have seen the power of strings, similarly we can see the power of languages also. Okay. So let me tell you about power of language. Suppose you were having a language, power is 1 actually. If at all the power of language is 0, what does it mean? It will still have epsilon. If you have power 2, it is concatenation of the language. Power 3, it means 3 times concatenation of the language. If the power is n, you can understand it is language to the power n minus 1 into l, means n times concatenation. As you have seen the clean closure and positive closure for string, similarly you can have clean closure and positive closure for languages, clean closure of language or positive closure of language. So clean closure of language, it will be all the possible concatenations, L to the power 0, union L to the power 1, union L to the power 2, union so on to union L to the power m, and to union whatever possible powers can be. Okay. If I tell you about L plus, what it will be? It will not have this portion L0. It will start from L1. That is the only thing. L1 union L2 union, these kind of things. Now these things, whatever union is performed, what do you think? There was something called universal language sigma star. This we have performed the clean closure of this particular language. Will it be a subset of this universal language, or it will become a superset of this universal language? Can you guess? My question is, you have performed this clean closure on a language. In a way, what has happened, there are multiple possible concatenations of this language, and whatever possible strings with the language are there, it is being generated. Now the question is whether this L, clean closure of L and universal language, what is the relation between it? Whether this is a subset of it or a superset of it. What do you think? Tell me. Some of you have to answer. Let me, okay, name Chavi Rana. Can you tell me?
Sir, please can you repeat the question, sir?
Question is, L star is a clean closure of a language, and sigma star is clean closure of alphabet. Clean closure of language, you have seen it is union of all the possible concatenations of language, and sigma star you have seen it is all possible strings on the alphabet. Now the question is, this L star is subset of sigma star or superset of sigma star?
Sigma star is the concatenation of strings. Am I right?
No,
You told
you are wrong. Sigma star is all possible strings with A and B, if at all sigma was having two symbols A and B.
and L star was
Here it is
Concatenation.
concatenation of L, only L, many times. L it is only once, 2 times concatenated, 3 times concatenated, and many times concatenated.
So I guess, sir, it will be L star will be superset of sigma star.
L star will be superset of sigma star. Superset means L star will have some strings, some possible strings which was not present in sigma star.
That's my guess, sir.
Any other guess?
Only two possibilities are there, so either it will be true or it will be false, sir.
Yeah. Abhishek, Raj, what do you think?
I think it is the subset because sigma star produce all the alphabets or collect sets of alphabets, string, and it is just a concatenation. So it is the subset. L star is a subset of sigma star, and sigma star is a superset of L star.
Okay, definitely it is something like this. Suppose your L is having a set of strings, suppose A and AB. Okay, let me make it simple. Control Z. Only AB. Okay, if you are performing L star, it means you will have L1, which is itself AB, L2, which is AB, L3, which is AB, 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 and so on, right? So if you will find the union of this, it means you will allow AB, you will allow AB, 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 AB. In a way, when you will see regular expression, you will be able to write this as AB to the power whatever, star, no, not a star, positive closure. Okay, at least 1 times AB should be there. So this is a possible things to write these all, the concatenation. So this is, you can now understand that this is generating only the concatenation of AB, 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 AB. Okay, it cannot generate BA, 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 BA. Okay, it cannot generate other things, B, 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 B. So sigma star is having all the possible strings. However, whatever language it was always a subset of this. So you will find whatever you will do, how many times you concatenate it, it will remain a subset of the universal set. Okay. Now, next class we will see further. Maybe I will think what we will see. Maybe we will see grammars or we will see regular expression. I will see what is, I believe regular expression will be better, I think. We will see in the next class. Till then,